Hi, my name is Kirsten Jowett. I'm a proof of location specialist and I produce the podcast Lay of the Land, all about proof of location. I'm also a PhD engineering and IT student at Melbourne University. I will be your moderator for the next 2 hours. I'm very pleased today to be able to introduce our first group of speakers from IRNAS and Smartparks, Tim Van Dam, Luka Mustafa, and Blas Brutus. Smartparks and IRNAS will talk about their design for Rhino implants and Collar LoRaWAN trackers. Welcome, Tim, Luka, and Blas.
Thank you.
Hi.
You can go ahead and share your project with us.
Okay. Luka, shall I start off or?
Go ahead, Tim. Go ahead.
Okay, cool. Let me share my screen with you. Okay. So we are from Smartparks, and together with IRNAS, we have designed some really cool and very good working LoRa trackers for actually a very good purpose, and that is the purpose of protecting wildlife with passion and technology, as we call it. I will give you a short introduction on what Smartparks is and what we are doing. And then we can dive in a bit deeper into the particular sensors and applications we have. So how we work in 5 steps. When a protected area in Africa approaches us or we approach them, we do a study on the lay of the land. We try to identify how we can build a LoRaWAN network. We select a set of sensors that can be used, ranging from vehicle sensors, Rhino sensors, animal sensors, ranger trackers. Then these sensors are deployed in a network, and we can gather all information in the control room via our web application. And then the use of the whole application starts by park management to actually protect the animals and to manage the park. So we have a very wide list of applications ranging from animal tracking, food patrol, tourist safety, road safety, access control, intrusion detection, movement detection, human presence monitoring, fence protection, environmental control, and of course all kind of adjusted concepts, because every park has different needs. This is This is the core team of Smartparks. So me, myself, Laurens de Groot and Jeroen de Loze, working mainly from the Netherlands. This is a screenshot of our front-end application. So this clearly shows the movement pattern of a wisent in the Netherlands, actually also a protected area along the coastline where these big European grazers are being reintroduced in this coastal area. And here you can see a lot of LoRaWAN GPS data plotted on the map, so you can actually see what are the long-term home ranges of this animal. Currently, we have deployments all around the world, but mainly focused at Africa, where the need for wildlife protection is very, very big. And we are specialized in rhino tracking, where we have 70 rhinos under our tracker management, let's say, which is already quite a big part of the protected population, unfortunately. Some of our clients or people we work with, ranging from African Parks, Peace Parks Foundation, WWF. So really like to work with all of them. Besides from the LoRaWAN, what we also work on is private 4G networks, mobile smart parks, and data analysis. Some of our technology partners, very, very important to us, and I think you can recognize a lot of known LoRaWAN brands here. A little bit deeper about how this technology supports park management and wildlife protection. So by collecting all kinds of different sensor information, ranging from biometric scanners, camera observations, but also our sensors attached to vehicles and animals and fences. You can also think about thermal imaging, which is more and more used, acoustic fibers along the perimeters of the park, but also drones are being deployed for scanning the areas. And recently we've started also with AI models and tiny machine learning models, which is, I think, a very exciting path to follow in the next months, also with all the Things Network partners. Then all these sensors information are being analyzed, most of the time even in real time. Then also the historic data is being retrieved from the databases, because these sensors generate a huge amount of data. And this results in threat alerts, meaning the rangers are being dispatched to the areas where there are threats. This can be threats based on real-time triggers, meaning a large group of animals is in distress, or an elephant is moving very fast towards a broken fence line, going to be disturbing a village. Then sometimes the helicopters are going to be dispatched, or a ranger team that is close by. Some case studies, which we can also discuss a bit deeper later, is our Rhino tracker, which we have developed together with IRNAS and a lot of partners around it to get it really where it is now. A couple of years ago, we really started with LoRaWAN and Rhino conservation to try and develop a very small sensor, which you can see on the left side of the screen, to place that in the horn of a rhino, to get it in there and to track the rhino for at least 2 years, because in 2 years this grows out. We needed to have this form factor, because otherwise it grows out faster, and you need to sedate the animal every time you put it in. So this was the form factor. Having this, we managed a couple of years ago to do this with geolocation in the LoRaWAN network. We had a position of every 7 minutes on this rhino, but in some areas it's very hard or even impossible to get always a 3 gateway constellation to do the geolog. So we already knew then that we needed to have the holy grail, which is GPS positioning in combination with LoRa. But obviously we also know that the power constraint of this device is still the same. So back then the GPS chips and antennas were not good enough to do the job. But recently we have managed to pack it all together, and now we actually have this tiny block which can do GPS fixes and send it over LoRaWAN to the network, giving a very accurate location on the threatened rhinos. Which is a world first, and I think very, very good example of what the power of LoRaWAN and together with other technologies can bring to the world. Another case study we really like is the elephant tracker. So I think over a year ago we launched the Open Collar initiative on the Things conference, actually in Amsterdam, which is about designing and open sourcing an elephant tracker, which is very often used in protected areas, because these huge animals, usually bulls, can become really dangerous in terms of disturbing behavior. That's not so much inside the park, that's much more about these big, huge elephants moving out of the protected area, these fenced areas, into the villages. If you look at the map on the right side corner, you can see the perimeter of a national park we protect in Malawi. And you can also see, if you look closely on the map, you can see that there are all villages all around the park, on the left side and on the south side, on the downside. So you can imagine if these huge bulls, you can see it on the top right corner, big bulls are marching into these villages, then they can cause quite some trouble, looking for food actually most of the time. So troubled elephants tend to be collared, so the rangers are really know where they are actually, and they can stop them before they break the fence and move in. So, but the problem was these collars were very heavy. They were very, very expensive, or are still very expensive. And this is mainly due to the fact that they always work on satellite connectivity, which tends to be quite heavy because of the antenna, and two, because of the batteries involved, because it's quite power consuming. So we try to break all of these rules, let's say, and make it very lightweight, and therefore it needs to be low power and connected to the LoRaWAN network we already have. So currently, well, you actually can see the tracks of this first open collar elephant tracker deployed on an elephant in Malawi. And it generates a GPS fix every 15 minutes and sends it over LoRaWAN. And it can last for 8 years or even more, which is amazing, because this means this collar is going to last very long, certainly compared to what they're currently using, and also the costs are very low. So we're trying to really put this in the market, as we say, for around 500 euros, which is very, very cheap compared to the current trackers, which are about 3,000 euros. So we really hope with this approach to get more animals safe. And as you can see on the left side, we did quite some engineering together with IRNAS and also with Lacuna Space, because this concept really still allows for quite a big antenna to do Earth to space communication over LoRaWAN to the Lacuna network, which is of course very useful when the animal moves outside your local LoRaWAN coverage, which is possible in some cases, because these elephants have huge ranges. Besides that, we also try to really train local people. With local, we mean where we do the deployment, so mainly in Africa, hoping to establish a knowledge base where we can really rely on in the long term. Also, when we are not here anymore, we really hope that the locations can pick up and maybe even start developing their own applications and sensors in the long run. Some pictures of the rhino, of the elephant collaring. You can see it's a huge animal. Close-up pictures of the components, the tracker. This is the Things conference with the actual collar. Here you can see the comparison between, let's say, a conventional elephant collar and a Smartparks collar, which is a bit crazy. You can see very high number of updates, and this is of course the rockstar team at IRNAS working on the Rhino tracker with the mold. And worked also together with Tauglas, who actually helped us in trying to tune the GPS antenna, which was, I think, the biggest hurdle in the whole development of this tracker, because the absence of the good ground plane and the detuning of the whole reception due to the potting had a huge impact on the reception of the antenna, on the resonance. Therefore, we really tried to reach out to Tauglas to help us with getting this right. You can actually see that this antenna was hand tuned by the scraping of the antenna. And here you can actually see the fitting of a sensor inside the horn. And this is actually an early prototype model, because currently they have a bit stronger epoxy resin. This is transparent still. And that's it. So Luka, do you want to take over?
Perfect. Yeah. So I can jump in. Maybe in the Rhino tracker, we go in for a bit more details. Meanwhile, I've seen a few questions in the chat. So Tim, these are for you. So the Cat City is asking about. How do you keep the information from the poachers? So asking if you are using TTI or something similar. And Ravi is asking about how many gateways do you need for local coverage, and how does the network look in that perspective?
So it really depends on the area. But for example, in Malawi, where you could see the elephant tracker, we are still using a Semtech server from the early days, and we are also using a chirp stack. And for most of our development and testing, we are using the Things network. So we are actually using a whole bunch of LoRa servers, depending on the specific need. The Things network really helps us to do cross-border testing, because it's always live and it always has the latest features. And it really helps us to make all these sensors like bulletproof. And IRNAS also really works with the Things network, so it is a perfect tool for us to work that way. And with local deployments, we really need to make them local most of the times and have full control. And we tend to do that with ChirpSec at the moment. So the other question was about the number of gateways, I guess. This also depends on the area. So you can imagine that if a park is the size of a province or sometimes a small country, it's also a bit about costs and also accessibility. So some parks are very remote, so you cannot reach to all locations. And also it depends on if you really need or want geolog. So now that we not always need to have geolog anymore, because we can do it with GPS, we tend to deploy less gateways. But for example, in the park where the elephant tracker is active, we have about 16 gateways active on very high locations. Sometimes we even have towers of 30 meters built, but sometimes we use huge mountains where we only need 5-meter towers. But usually we use the Curlink IBTS with antenna diversity, so we tend to use 2 antennas to really get the maximum out of the gateway.
Cool. So I think we can jump a bit more into the Rhino tracker. I hope you guys can see my shared screen. Yeah, we can talk a bit more about how this is built. So you see images, of course, of the Rhino tracker here. The 3D model is probably easiest to talk about in this case, because the real challenge here is making the device as densely packed as possible with all the features and in the smallest form factor. So this is governed pretty much by the battery, which is a soft primary cell LS14250 battery in this case, with 2 PCBs attached at the right angle to really minimize the size, one being for GPS and one being for the LoRa transmitter, but also this configuration particularly allows us to essentially seal all the RF components between the two boards and the battery, such that when we epoxy pod the whole solution, we don't disturb essentially the RF properties of this. So there's been quite a lot of work just figuring out how do we make this in a small factor and make it very robust. So Blush can talk a bit more about the mechanics and the potting process, like how do we take that piece of electronics and make it robust?
Yeah, hi. Well, actually, the main part here was to make it as robust as possible, so the tracker can withstand the environment that it is in. So taking the electronics, make it waterproof, make it robust. That's why we decided to pot it in a resin. But the problem here was that you do not have a lot of space around the tracker, because you still want to have the smallest possible form factor. So we put a few millimeters of resin around it to ease all the applications and to put it inside the Rhino horn. At first we were using the clear resin, but it wasn't strong enough, so we moved to some other resin, and I think that we have quite a durable product now.
Perfect, Tim. So what's your experience with using this in the field and testing, as you've seen a lot of different options already?
Yeah, so I think it's all about testing, and currently we are super happy with the current status we are in. So I think we did quite some iterations, starting with the transparent resin, but even that version, there are still some active at the moment, and they are still working. So they are walking. Let's say the rhinos are walking around, and I can see it live on the screen. And so even the early prototypes, some of them are still working. We also know that some of them failed, and I think we can talk a little bit about the cause of this, about the battery, and I think you can explain that very well, Luka. But let's say the end state where we are now, the current version where we have the black resin, which is a bit more sturdy. Yeah, it's super durable. Of course, we have to wait for 2 years until it grows out, that we really know. But I'm super confident that it's working, because currently there are no signs at all that it's not working. So I'm super happy, and also because we ship them to the local parks very remotely. And they do the deployment via veterinarians without even us being there. So we completely monitor this whole deployment remotely. We have test operations, so it's also good to talk a bit about the firmware maybe. But I feel very confident. Now we know the battery issue, let's say, we know how to handle them.
Sure, so we can dive a bit deeper into that. So given this is a really small size constrained device, obviously the batteries that are available, primarily lithium thionyl chloride, have very limited characteristics. Whereas with GPS, you need your 30 milliamps for the time of the GPS fix. So there's really no good way about getting around that. And essentially we need to accept that the total battery capacity that's advertised and available in normal conditions is not really available in this trackers. And really the whole firmware and the logic around this is built in a way where devices will be asleep most of the time and do a GPS fix every few hours as we configure them. minimizing the power, obviously, of that through almanac retention and through a local running RTC. So we always try to keep as much of the hot start mode as possible if the fixes are not too far between the two. But yeah, we very well characterize this in all the conditions. So we know how it operates in the lab. We know how it operates in the field, and with data analysis, essentially of everything, we've quite fine-tuned the design by now to be able to do all the features remotely. How GPS operates is quite interesting because we always set the precision we want from the fix, so we get the minimum fix time. For example, for normal applications, you can do fixed precision of like 50 or to 100 meters or something like that. And if you need a more precise position, you tell the GPS that through a downlink, and you get that one instead of wasting power and always getting a very precise position. At this point, I think we can quickly also jump to the Lion Bison tracker and the Ranger tracking. So this is a different design we came up with, and I'll share my screen again to show a bit more of that. So this is essentially a bigger version of about the same solution as in the Rhino tracker, but made to last much longer, be more robust and more efficient, with also external power input. And it's also a fully potted solution. So, Blaž, I guess you can show us a bit more about how this electronic turns into a fully potted product. Or talk about more about why also we have a piece of PCB sticking out for mounting and programming and so forth.
Yeah, well, you can see on this screen here the process from the base PCB to the finished product, all the steps. So the first thing is just electronics, and the last step is to pot everything into the resin. The PCB that is sticking out is there for the programming. So the problem when you pot the electronics into the resin is that you cannot access it anymore. So if you do not have any connectors or a PCB or anything like this sticking out, you cannot upgrade the firmware, for example. So that's why we leave this part out, so you can access it. But on the other side of the tracker, this is not seen from the picture here, are two standoffs that are sticking out of the tracker that are meant for the charging. So this was designed in a way to be as easy as possible for the local guys to use. So if you want to charge it, because this one has a rechargeable battery, you just connect it to any DC power up to, I think, 30 or 40 volts. So you can basically charge it anywhere from a car battery, for example. So it was really designed in a way that it is as easy to use as possible.
Fantastic. Thank you, guys. And I'm very interested to know how many iterations you went through to get to this point.
Well, it was a combination of multiple projects, because we were doing the Rhino tracker and the Lion tracker. So some of the components are similar. So, but together we've done a few iterations, because even though if you start with a prototype that is already working, there are some things that you want to change, and even when you have a final version, there's still something that you would like to change. So this process can go on forever if you want to. There's always something to upgrade.
Great. And it seems like the price is a really good price point, especially considering that the GPS is a power-hungry component, but you wanted to keep it low power for the LoRaWAN. Are you happy with where that is and your new plans going forward for the next iteration?
Tim, will you take this one?
Yeah, so yeah, we're super happy with how it goes. So also this tracker is part of the what we call Open Collar project or Open Collar initiative. Therefore, everything is also open source available. So please check out the GitHub repositories. You can find, let's say, the master at IRNAS GitHub, but you can also find the latest production version at the opencollar.io GitHub. But we are super happy where we are now because of the fact that we are using them in the field, and I think that's the only real proof. For example, I've one here, so they're in the field and they're working really nicely, and you always have ideas about new features and stuff. But yeah, currently I'm super happy, and also I think. There is nothing else that can do this in this way and be this tough. To be honest, we always look first for available sensors in the market that are there that can do the job. And if they are not there, we're going to do R&D, because everything we do is non-commercial. So we have to do fundraising for every single euro or dollar we spend. But yeah, there's nothing like this in the market. So I'm really happy that we pulled it off and are at this stage where we have a tracker to use on rangers, vehicles, but also put it in a different form factor where you can use it on lions, cheetah, wild dog, and all threatened animals.
Great. Congratulations. One last question we have before we wrap up. Andre Ramirez asks, what LoRa module did you use?
So we use the Murata modules in all of these projects at the moment. So these are Murata ABZ SD processors combined with the LoRa transceiver. So this is a safe and stable design, and we're now slowly looking to move forward towards later transceivers and newer solutions as well.
Great. Thank you so much, gentlemen. Good luck.
Welcome.